Bristol Community College, Mathematics with Dan Avedikian, Math 011, Arithmetic, Section 4.9, Problem 13. This is Section 4.9, Problem 13. It says find the final amount for $10,000 invested at 12% interest compounded monthly for 20 years. So this is very similar to the previous problem. The previous one is just simple interest. This one is compound interest. And you'll see there's a big difference in the answers. So anyway, which formula do you use? Simple interest or compound interest formula? Because this question talks about compounding, you have to, of course, choose the compound interest formula, which is A equals P times, in parentheses, 1 plus R over N to the N times T exponent. And fill that in. A is the final amount that we're looking for. P is the principal or initial investment, which for this problem is $10,000. Open the parentheses. 1 just stays as a 1 plus R. So R is the rate as a decimal. So this problem says the rate is 12%. As a decimal, that 12% must be written as 0.12. That's the rate as a decimal. N that goes in next is the number of times compounded per year. So this problem has monthly compounding. So at the end of every month, the bank takes the interest that you've earned and it puts it in your account, and you earn interest on that too. So 12 months in the year, number of times compounded per year is 12, because 12 months. So N, number of times compounded per year is 12, because of the monthly compounding. Close the parentheses, exponent of N times T. N, again, number of times compounded per year for monthly compounding is 12, times T, the amount of time in years. So the question says 20 years, which again is the same as the previous question. So T is 20. So that's how it fills in. Now, as we start doing the math, you have a lot of things going on. It's 10,000 times the parentheses, even though they don't indicate an operation. It's understood to be times. You have work in parentheses, and you have an exponent. Which one has to be done first? Well, with any type of math that I know about, if there's parentheses, you have to do the parentheses first. So let's start with the parentheses. Even within the parentheses, there's two operations. You have an add and a divide. You have to do the divide first. It just has a higher priority. You have to. So we can have A equals 10,000 times the parentheses, in the parentheses 1 plus. The 0.12 divided by 12 becomes 0.01. Now again, where does that come from? I took this fraction of 0.12 over 12. I put the numerator in the calculator, put divide, put the denominator in the calculator, hit equals. That's where the 0.01 comes from 0.12 over 12. The calculator will do that for you very quickly. The exponent, 12 times 20, I can leave it as a 12 times 20 until I finish the parentheses, but there's actually no harm in really simplifying a little bit right now. So again, that's a big multiplication. I ignore the 0 just for a sec. 12 times 2 is 24. Very simple. That'll put the 0 back. 24 with 0 after it, 240. Now, you're almost done with the parentheses. There's an addition left. It's a very easy addition. So you'll have 10,000 times the parentheses. In the parentheses, 1 plus 0.01 is 1.01. And you have an exponent of 240. Let me make that a little neater. Now, there's only two operations left. You have a multiply, 10,000 times the parentheses, and you have an exponent. The parentheses to the exponent, 240. So it's not 1.01 times 240. It's 1.01 times 1.01 times 1.01 times 1.01, 240 times. That's a lot. That's not something you want to even think about doing without a calculator. So I'll leave the 10,000 in front, and I will rely on my calculator to get an answer for this extremely immense exponent. So if you have a calculator with an exponent button, really this one has to be done with a calculator with an exponent button. You enter the base of 1.01, press the exponent button, which may look like that up arrow, and then you put in the 240 and you hit equals. Now, depending on the version of calculator you have, the exponent button might look like this, x to the y. So again, put in the base, 1.01, press your exponent button, which it'll be one of those two, and still put in the exponent, press equals. So that's what I'm going to do at this point. I'm going to take my 1.01 and raise it to an exponent of 240. I'm going to rely on the calculator to do that. So to start off, I'll make sure the screen is clear. I'll put in 1.01, press my exponent button, and then put in 240, enter. So in the parentheses, I'm going to have 10.89255365. That's the result of 1.01 times itself 240 times. So I still have to do 10,000 times that number. Now again, I got a lot of decimals when I did that. More than I need, and I will round, but not yet. This number is on the screen of my calculator now. I want to just leave it because what am I going to do with it? I'm going to multiply times 10,000. So just leave it on the screen. Hit times 10000, 4 zeros, equals, and the calculator says the answer is 108925.5365. So now I'm going to start rounding. So now I have 4 places after the decimal. Now in terms of money, more than 2 places doesn't really have a lot of meaning. So I want really just 2 places after the decimal. So when I go to the 3rd place out, it's a 6. That's big enough to make this 54 cents. So my final answer, when I put in the commas, you'll recognize this as $108,925, and with round off 54 cents because the 6 was big enough to make the 53 into a 54 cents. That's a big difference in the previous problem. So in 20 years, a very long time. So if you go back and reference the previous problem at 12% simple interest for 20 years, it came out to $34,000. That's a lot of money. 12% compound interest, though, for 20 years, a little over $100,000. That's a lot better than $34,000. So the compound interest for 1 or 2 years, the answer is almost the same. Compound interest for, say, 10 or more years, huge difference between simple and compound interest.